Alright, video number 1 for the actual lesson. So the factoring video was optional. I didn't include practice, but if you need it, email me and I'll give you practice. Um, Video 2, we're doing multiplying and dividing rational expressions. A rational expression is anything that can be written as a fraction. So I typed those, but I'm going to actually rewrite them because it's a little easier to see. So 1/2 divided by 2/3. So this is how multiplication and division work with fractions, and rational expressions are fractions, so they're going to be similar. Multiplication, you just multiply across the top. So just 1 times 2, 2 times 3, and you can simplify your final answer by finding a common factor that you can divide out to 1. 2 divides out, so we end up with, which is both of those divided by 2. I know, crazy lesson, right? So, second one, division, it works almost the same as multiplication, but if you ever see a division sign, you need to flip the second one and multiply. And what I want to see is, if you're doing this on when I'm with you, you're going to be rewriting the problem as a multiplication problem with this part flipped. 1 times 3 is 3, 2 times 2 is 4, and once it's a multiplication problem, well, we just talked about that. So you'd also need to look to see if it can simplify, but there's nothing that divides out of each term. But that's like elementary school stuff. So nice little review, but let's look at something more real. So here we got a similar thing. It just has a variable in it now. So we're going to do the same process. It's multiplication, so we don't need to worry about any flipping. 3a to the 5th times 2 is 6a to the 5th. 4 times negative 15a cubed is negative 60a cubed. Then we do have to simplify, see if there's something in common in the top and bottom, if there's a factor in common. The numbers both divide by 6. So 6 divides by 6 just to get 1. Negative 60 divides by 6 to get negative 10. Then we can look at the a's. Technically there's 5 a's up here and 3 a's down here. Each a in the top and bottom can divide to 1. Anything divides by itself to get 1. And can effectively cancel. I don't like the word canceling, but dividing to 1 means it just multiplies to what we have and stays the same. So anything that divides to 1 will basically disappear. So what we got left is 1a squared over negative 10. Or you could just write a squared over negative 10. You don't actually have to write that one. That is our result. Seems easy, maybe not so bad. I'm going to do one division problem as well. Division problem, remember, you do need to flip these two and then multiply, so I want you to rewrite it. So I left the whole page, sweet. So 5 over 8a to the 6th times, you're going to rewrite it as a multiplication, so 6a to the 4th over 5. Some people start simplifying beforehand, so like realizing that these two 5's can simplify because they're already going to be a factor on the top and bottom. I'm going to do that. You don't have to. You can simplify out the end. But I do see that those are going to simplify, so they're not going to be a thing. I also see that those both divide by 2, so that's going to make life a lot easier later on, because this will just become a 3, and that'll just become a 4. So I'll 3. I do need to simplify the a's though. If there's 4 on top and 6 on the bottom, we can use this dividing to 1 trick and just think how many would divide to 1. And 4 of them would. All 4 on the top would disappear because there's a smaller number up top, but there would still be 2 left over at the bottom. So 3 over 4a squared, and we have it. and we're in good shape. I will teach you another. So there is one thing about dividing that is important, is we're not allowed to divide by 0. So if your result or your problem has a situation where you could divide by 0, that answer would be an undefined value. So this answer divides by 0 if a equals 0, because if a was 0, then 4 times anything that's 0 is still 0. So this could not be true when a equals 0. So I'll write just a cannot equal 0. Similarly, up here, if there's an a at the bottom, right there, you can't have a 0 as a, because negative 15 times 0 is still 0. So I also have to state, even if it's anywhere in the problem, that a cannot equal 0 here. It's called an excluded value. It's called, I'll write it here, excluded value. And you'll see those. Or an undefined value is another way of seeing it. So, you all have a good one. I'm practice the con. I will be making the next video, and we'll see how we do.